token ring is a totally different type of network technology that was developed by IBM. The purpose of token ring was to eliminate collisions on a network. As you remember, collisions in Ethernet caused the network to stop. So this was a disadvantage in the earlier days of Ethernet, and token ring was the answer. With token ring, the computers appear to be connected in a star. In other words, physically they are connected in a star. Each computer is connected to a hub-like device. This device is actually called a multi-station access unit, or an MSAU. And these devices are connected in such a way as to form a ring. So although physically it looks like a star, logically token ring is a ring. Now compared with Ethernet, token ring is more robust and more reliable, but it's also more complex and more expensive and more difficult to maintain. Token ring cables can be unshielded twisted pair or shielded twisted pair that have two twisted pairs or a total of 4 wires in the cable. With token ring, communication is controlled by a token. A token is a small frame that constantly travels around the ring in one direction. And when a station seizes the token, it controls the channel until its message is sent. As a matter of fact, once a computer seizes the token and sends a message, the message must come all the way back around to the sending computer before another token will be released out onto the wire that another computer can have. So as you can see, with token ring, we do not have a contention system. Only one computer can use the network at a time because there's only one token, and the computer must have the token in order to gain access to the network. A faster type of ring that was developed later on is called the FDDI ring. FDDI, Fiber Distributed Data Interface, does not require a centralized hub, making it both logical and physical as a ring. It's often used as a backbone network to link several networks together, and most of the time it uses fiber optic cabling. FDDI has dual counter-rotating rings, so the token travels around the ring. But if the ring were to break, the token can go to the inner ring and keep traveling in the secondary ring. Most communications will be in the outer ring or the primary ring, but there's a secondary ring in case there's a problem with the primary ring. Communications with FDDI can be much faster because the computer does not have to receive the message back before another token is released onto the wire. So we can actually have many messages transmitting around the wire at the same time, but only one token. So FDDI is not a contention-based system either. The computer must have the token in order to transmit, but FDDI is much faster than token ring. Next, we'll talk about some types of network hardware that are used with the different network technologies.